This video lesson is going to explain how and when to use inequality notation and how and when to use interval notation. The first thing we need to understand is the difference between a linear equation and a linear inequality. For example, a linear equation might be something like x equals 5. An equation is just something that has an equal sign with a variable and something on both sides. To be linear, that variable is to the first power. It might be something like 2x plus 1 equals 7. That's a linear equation. An inequality is something that instead of using an equal sign uses a less than or a greater than sign, or maybe less than or equal to or greater than or equal to. So it might be something like x is greater than or equal to 5, or 2x plus 1 is less than 7. And in terms of graphs, the solutions to linear equations are typically just one single number. Sometimes you get no solutions or all real numbers, but most of the time you just get one number. So if I were to graph the solution to x equals 5, it wouldn't be particularly exciting. I would just come down here to the number line to 5 and put a solid dot on it, and that would be the graph of the solution to the equation. So we typically don't draw the graphs because it's just a single dot on a number line. Similarly, the solution to this one is 3. So if I were to graph the solution to 2x plus 1 equals 7, I would just put a dot on 3. But when you have an inequality, instead of just having one solution, you actually have an infinite number of solutions that satisfy that. For example, 5 is a solution to this because 5 is greater than or equal to 5. It's actually the equal part. 6 is a solution because 6 is greater than or equal to 5. 10.2 is a solution because 10.2 is greater than or equal to 5. If I were going to graph the solution of this, I would have to start at the number 5, but then every single number out here to the right is the solution. So I have a whole, actually half of the number line. Any number to the right of 5 is a solution. And you'll notice here that if you plug in 3 would make the left side here 7. And 7 is not strictly less than 7. So 3 is not a solution. But I think if I picked a number like 2, 2 times 2 plus 1, that is less than 7. So I could put a dot on 2. 0, 2 times 0 plus 1, that's less than 7. I could put a dot on 0. So if I wanted to graph these, it's going to turn out that any number up to 3 is going to be a solution, but not 3 itself. So I would need to shade all of these numbers over here to the left. So the difference between an equation and an inequality is, well, first one involves an equal sign, the other one involves less thans or greater than signs, or less than or equal to or greater than or equal to. But also that equations typically have one solution if they're linear, but inequalities have an infinite number of solutions. They're entire chunks of a number line. So we have to know how to write our solution sets. So I'm going to talk through how you properly graph an inequality, and then how you convert it to something called interval notation. So what I've got here is a table that includes a bunch of inequalities, and I want to create a graph and an interval. So for this first one, x is less than or equal to -1. You just want to mark where -1 is on the number line. And then the first thing is, if this inequality includes an equal sign, then we're going to include the -1. And there's two ways to show that. One is with a solid dot, and the other is with a square bracket. And I'll show you what I mean by that in a second. Let's start with the solid dot. And then I want to shade the side of the number line that would satisfy this. So what numbers would I plug in here so that these numbers are less than or equal to -1? Well, those are all the numbers over here on the left side. So my number line would be shaded over here to the left. Now, if you want to use the other notation for the endpoint, and I'll show you where that comes from, if you're including the endpoint of -1, then you use a square bracket, and you usually open the square bracket sort of to the side of the shading. Now, interval notation is a different way of writing this same inequality that describes which section of the number line you're taking. And interval notation doesn't involve a variable, it doesn't involve a less than or a greater than, it just involves two symbols, one that represents the left-hand number or the lower boundary of your shading, and the other one is the right-hand number or the upper end of your shading. So in this particular case, if I look at the graph, the left-hand side of my shading, well, this goes on forever. Well, so what's forever in the negative direction? Well, forever in the negative direction is -infinity. And if I ever need it, forever in the right direction is +infinity. So my left-hand boundary for this shading here is -infinity, and my right-hand boundary is -1. Notice there's no variable in interval notation. And then what I always put around things is either parentheses or square brackets. So around infinities, because you never get there, you use round parentheses. Anytime you never get there or never touch the endpoint, you use a round parentheses. If you actually are including it, you use the square bracket. And the square bracket from interval notation is how this notation in the graphs came about. If I do x is greater than 3, first I want to find 3 on my number line. Because this is greater than 3 and it does not include an equal sign right here, I'm going to use an open dot, and then the numbers that are greater than 3 are all over here to the right. Doesn't like my blue pen for shading, so I'm going to shade with the highlighter. I can do it that way. The other thing I can do is put a round parenthesis here. That means the same thing as an open dot. And so my interval notation, if I talk about where my shading is, that's over here. The left-hand side of that is 3. The right-hand side, well, it goes on forever, which means it goes out here to +infinity. So I'm just going to put an infinity symbol. I never get to infinity, so I'm going to use a round parentheses. And actually, because it's not equal to 3, it's actually an open dot, then I'm going to use the round parentheses. Now, sometimes people get confused if the variable is on the right-hand side. So if that confuses you, you can change the direction of that, or you can move the side that the x is on. But if you do that, you need to make sure that the arrow is still pointing at the same number. So up here, it's pointing at the 1. So 1 less than or equal to x is the same thing as x is greater than or equal to 1. Notice that if I took a number like 3, and I plugged it in there, 1 is less than or equal to 3. That still works down here. 3 is greater than or equal to 1. So if I'm going to graph this, 1 is less than or equal to x, or if I want to think of it as x greater than or equal to 1, I'm going to come over here to my number line. Because this has an equal sign, I'm going to put a solid dot. And then the numbers that are greater than or equal to 1 are over here to the right. And so my interval notation, it always goes left to right. My left-hand boundary is 1. My right-hand boundary is +infinity. Infinities always get the round parentheses, and because this has an equal sign over here, I'm including the 1, which means it gets a square bracket, which also means on my graph, if I wanted to put the square bracket instead of the solid dot, I could. Okay, a couple more. -2 is greater than x. If I want to flip that around, I can put the x on the left and the -2 on the right, but I have to still point the arrow at the x. So that's the same as x is less than -2. So I'm going to come over here to my graph, find -2. This is less than without an equal sign, so I'm going to put an open dot here. And the numbers that are less than -2 are over here to the left. So my interval notation, I always read left to right. The left-hand boundary is -infinity. The right-hand boundary is -2. I never quite get to either one of those, so I use round parentheses. And similarly, if you wanted to on your graph, you could put a round parenthesis on the end of that section of the number line. Okay, the last two examples here are compound inequalities, and it just means you need to know the difference between and or. So when you see an and, you're looking for an intersection or an overlapping. And when you see this symbol, which is a union symbol, that means or, which means that you're actually not looking for where the two sections overlap, you're actually taking everything that's involved. So let me do these two separate examples. So x is greater than -5. If I find -5 on the number line, the numbers that are greater than -5 are over here to the right. And the numbers that are less than or equal to 2, if I find 2 on my number line, those are sort of starting at 2 and going to the left. When you see the word and, you're looking for the intersection. So imagine I took both of these lines and I moved this blue line down here onto the number line, and I moved the red line up here to the number line, and I just took where they had both colors involved. And the section where they have both colors involved is going to be right here from -5 up here to 2 and the shading in between. So when you see an and, it often involves a sort of a in between two numbers. And this is the other way that you write that. This is read -5 is less than x and x is less than or equal to 2. So these are two things here are really the same thing. And notice in this notation, this x variable is between -5 and 2, and that's where we ended up shading here. Okay, so for interval notation here, it always goes left to right. My left-hand boundary is -5. My right-hand boundary is 2. The -5 is not included, but the 2 is solid. That is included, so I'm going to use a square bracket there. And I could put those symbols on the number line as well. Okay, last example here is an or. When you have an or, you're taking everything. Any place there's shading involved. So if I have x is less than or equal to 1, let's say 1's there and 4's here. X is less than or equal to 1 is going to be to the left, and x greater than 4 is going to be to the right of 4. And when it's an or statement, I just take all of it. So that's the graph of x is less than or equal to 1 or x is greater than 4. And just like I had to write these inequalities over here with this union symbol, when I do the interval notation, I also have to do that with a union symbol. So there's two separate sections of the number line, so I'm going to do two separate interval notations. This piece over here goes from -infinity to 1. And this piece over here goes from 4 to +infinity. This 4 is not included, so I'm going to use a round parenthesis there. So that's an introduction to interval notation and graphing inequalities.